Hello and welcome to DataCast Solutions, Statistics and Data Mining 101 using KNIME. In this chapter, we're going to look at date transformation. Systems and applications use a broad range of date formats to store dates, especially when they're not stored as a data type and are stored as character strings. And they have major impacts on the knowledge discovery algorithms that we're going to be introducing. So this is an important topic. Now, internally in a database, and including in KNIME, dates are actually stored in an internal format. And it's expressed to the user in a defined format that has been established usually by a system parameter that shows the standard format. So Europe can see a format one way and the United States another way, and so on. As a rule of thumb, a traditional YYYY for year format of a date is frequently sufficient for most data mining activity. Unless you're trying to do some very detailed time series analysis, often date in the form of year is sufficient. Representing a date in formats like year-month or year-month-day can be okay, but it introduces a real problem in that it doesn't preserve intervals. In other words, 2004, February 1st of 2004 minus January 31st, 2004 does not equal one day when you look at it that way. And this is going to introduce bias into your models. One solution is what IT came up with many years ago, and that's the unified date format. So in Unix, for example, dates are all stored internally as the number of seconds since 1970 began. In SAS, it's represented as the number of days since January 1st, 1960. Many other implementations by operating systems and databases store dates in different ways. The problem with it is that when you store it, for example, as a number of seconds since 1970, it's not easy for you to interpret and understand what it means, and it certainly is much harder for you to verify, which makes it much easier to make a mistake. One common solution is the KSP date format. What we do is we represent this as a year plus the number of days since January 1st minus 0.05 divided by 365 or 366 if it's a leap year. So let's try this as an example. September 24th, 2003 would actually come up as 2003 plus 267 minus 0.5 divided by 365 equals 203.7301. Now that still may look a little odd to you, but this format preserves the intervals and maintains readability. At least looking at this, I can see the year and I can at least see the quarter that it's in. So the format can easily be extended to include time, by the way. Now, 22 years later, I would have liked to think the Y2K issue had left us, but it hasn't. There are still some systems that store dates with two-digit years. For example, they'll store 02 instead of 2002. Or is it 1902? The typical approach here is to use a cutoff mark as the year. For example, we'd say if it's less than 50, assume it's 20YY. Else assume it's 19YY. That's really all you can do when dealing with Y2K issues. That completes this chapter of the class. Feel free to move on to the next chapter.